All right, well, I want to thank everybody for attending another Friends of Euclid Creek presentation. Tonight, we will be joined by Suneeti Jog, and her title for her talk is Assessing the Health of Wetlands. And tonight, she's going to speak about a few popular tools used to assess the health of wetlands. Her work actually started at the Dusty Goldenrod Preserve way back in 1999, which was the starting point of her journey into the world of wetland bioassessments. Her talk focused on floristic quality assessment index and indicator species as tools that can be used for the identification of high quality wetlands for conservation prioritization. Born and raised in tropical India, Suneeti has conducted research in this field for over 2 decades, spanning various wetlands in Ohio, upstate New York, Oklahoma, Kentucky, and currently Illinois. So it's with much pleasure to introduce to all of you Suneeti Jog. Thank you so much for joining us this evening.
Thank you very much. Thank you, Steve, and everybody else for attending my talk. I am really honored to be doing this. And this is the first time I'm actually doing a Zoom talk. So if anything sounds weird or something, sorry about that in advance. So I'm actually a field botanist, and I'm a plant taxonomist. But I've been working in wetlands for the past 2 decades or so. I've also worked in prairies and forested ecosystems, but I enjoy working in wetlands considerably. So most of my research program is centered around wetlands. So that's what I'm going to be talking about. So just as my title says, assessing the health of wetlands, I'm first going to give you a little bit of introductory information about what wetlands are and why we care about them, and then various tools that are used to assess the ecological health of wetlands, specifically bioassessment. So the use of biological criteria, the biota, and specifically vegetation to assess the health of wetlands. So for me, everything started with my advisor, George Wilder. I was a student at Cleveland State University from the year 2000. I met him in, I think either late 99 or, yeah, I think it was late 1999 when I met him. And I called him. I was very excited that there was a person working at Cleveland State University studying floristics, and that's exactly what I wanted to do. Can you hear me?
Yeah. Yes, we can. I just want to remind everybody to please mute themselves so we don't have any of that background noise.
All right, thank you. So when I talked to George Wilder, one of the first things he asked me was where I lived. And at the time I lived in Mayfield Village, which is very close to Highland Heights. And he was extremely excited. And right away he said, well, I know of this wonderful area called Highland Heights Community Park. And it's got this amazing rare plant. It's called a goldenrod. Have you heard of goldenrods? Do you know what they are? And thankfully, I heaved a sigh of relief. I actually knew what the genus was, because coming from a city of 19 million people, there was not a whole lot of vegetation to look at. And coming from the tropics, I couldn't tell what an oak was or what a maple was or what a hickory was for that matter at the time. But I had heard of a goldenrod and I said, yeah, that's the genus Solidago. And I acted like I knew everything about goldenrods. And he seemed very excited. And I'd like to think that that was when he probably decided that he would take me on as his graduate student. But he did. And I've since then worked at this preserve and many others. So last weekend, I happened to be in the Cleveland area and I took a walk down memory lane and I took this photograph outside the preserve. At that time, it wasn't called the Dusty Goldenrod Preserve. It was simply Highland Heights Community Park, which was all of this. And then adjacent to that was this property, which is now called the preserve, that was owned by the school district. And then there were many agencies, and I think Friends of Euclid Creek may have been one of them that helped preserve this place. But I was happy to see this picture of the goldenrod that I think I took. It's in my dissertation from many years ago. So this was the site, and this is a map redrawn from, or I picked it up from one of my own papers that I published in 2004. This yellow spot here is where that dusty goldenrod grows, that's Solidago puberula. And here's a picture of it on the right that Brian Gilbert took. There's in fact an enclosure now that has a bunch of plants in this meadow. And I believe some people go out there and take care of that. So I thought, because this is a Zoom platform, I can't really make eye contact with people. I wanted to make it a little more interesting. So I took a few pictures of plants while I was out there, and I thought I'd put them in at the beginning of my talk. So here's one on the left. Does anybody recognize what that is?
Yes.
Any
We're
guesses?
muted.
What is it? What milkweed is it?
Red.
It's swamp milkweed, and that's Asclepias incarnata. This occurs in that wet meadow, and there's an abundance of it right now. It's flowering, so if you want to go out there and look at it, it's absolutely beautiful. Just south of that wet meadow is a forest, and this one on the right grows in that forest. There are a few trees of this. Anyone recognize what this is?
Somebody in the chat said pawpaw.
Excellent, that's right. That's Asimina triloba, pawpaw, and this is actually the only species in this family that occurs in temperate North America. The rest of the species all occur in the tropics. So cherimoya is one of them, or custard apple, if anybody's eaten them. Pawpaw flowers early in the spring, and it's got these beautiful maroon flowers. And the fruits are really delicious if anyone's eaten them, or if you want to go look for them in the summer when it starts fruiting. I'm not sure if it does so here in Highland Heights, but elsewhere, bigger trees should be fruiting. The one on the left, any guesses? That's also from the wet meadow.
It's a sedge.
It's a sedge, that's right. What genus? I know Matt's in there, Matt Finsley. Do you know what genus it is?
That would be a sedge in the genus Carex. I don't know the species though.
That's right. It's Carex crinita. It's fringed sedge. And this was flowering, actually fruiting last weekend when I was there. The one on the right, any guesses? That picture is actually prettier than what it looks.
Yeah,
That's Prunella vulgaris, right?
That's right. Very good, self-heal. That's also in that wet meadow, which is called the Dusty Goldenrod Preserve. And then I have the one on the left. Anyone know what that is?
Oh, it's beautiful.
Yeah, it is beautiful. And there's a lot of it out there.
Not stevia. What's the plant?
Close, steeple bush.
Spirea.
Spirea, that's right. That's Spirea tomentosa. It belongs to the rose family, and there's quite a bit in the middle, right in the middle of that wet meadow, and it's flowering right now. So if you want to go out there tomorrow, now's the time in the next day or two to go look at these. And I cheated a little bit. The one on the right occurs in the wet meadow, but this is not the right season for it. So the picture is not taken from there. I took it last fall in Wisconsin. Anyone know what that is?
Alex in the chat said it was a white fringed orchid.
Yes, it's Spiranthes cernua, white
There you go,
lady
Alex.
stresses orchid. I'm not very good at the common names. Maybe fringed orchid is another. I thought that was Plantanthera, but maybe that's an alternative name. So like my colleague said, maybe these were the only slides that people will actually like, but hopefully not. I hope he was only quipping when he said that. So let me talk a little bit about wetlands. Let's switch gears and focus on on wetlands. So according to the US Army Corps of Engineers and the EPA, they've used this definition of wetlands since the 1970s for regulatory purposes. So they define wetlands as those areas that are inundated or saturated by surface or groundwater at a frequency and duration sufficient to support, and that under normal circumstances do support a prevalence of vegetation typically adapted for life in saturated soil conditions. So wetlands generally include a variety of different types. It can be swamps, marshes, bogs, but sometimes even things such as roadside ditches or prairie potholes or vernal pools that occur in the northeastern United States. These are actually dry for most of the year, but then they do have water intermittently during the year. Those are also considered wetlands. And then there are playa wetlands, which are actually bottoms of undrained desert basins. And these are sometimes covered with water. And I have a funny story about playas. So my co-author and I went on a trip to Arizona, and we saw this picture of Arches or Canyonlands National Park that showcased wetlands, and they looked so beautiful. And we work in wetlands, and this was July, and we said, we have to go out there and look at these wetlands. And we walked for miles and miles and couldn't find wetlands at all. And when we came to a realization, these are playa wetlands, they're actually going to be dry in July. And so much for being wetland experts. It took us several hours to realize how stupid we were that there wouldn't be any vegetation at that time of the year. So the point is that not all wetlands are going to look like this pretty little depression picture I took in Oklahoma that obviously has standing water. But sometimes you'll be surprised they don't always have standing water at all times of the year. So what makes a wetland a wetland? There are three things. There are the soils, the water, and the vegetation. In other words, you have to have hydric soils, the right hydrology, and plants that are adapted to this aquatic lifestyle. These are called hydrophytes. So for soils to be hydric, they should either be permanently or seasonally saturated by water. So typically soil scientists go out along with botanists when there are wetland determinations to be made. I currently work at the Illinois Natural History Survey, and part of what we do is, or a big part of what we do is contract work with the Illinois Department of Transportation. So every time they have to build a road or do any kind of road work, expand it or rebuild a bridge or anything like that, we have to make wetland determinations within that project corridor. And for that, we have botanists and we have soil scientists that go out and look at the plants and soils. So a soil scientist typically carries what is known as the Munsell color chart. And here's a page out of that. It's got, you would read it like this. This is the color or the hue, the value, and the chroma of the soil. And if you have this type of a soil in your wetland, you would call it 10YR because that's on the page, on that particular page, 7 and 3. That's the designation of that soil. So wetland soils typically look like this. They're gray or brownish gray, and they might have these redox colors, iron deposits in them. They have this orangish hue to them. And then there's this whole soil horizon that they look at. And I'm not really an expert at that, but if all you have to do is look for these colors, you can actually get this Munsell color chart and determine whether you have hydric soils or not. So the second component of a wetland is the hydrology, and there are various indicators for hydrology, and I've listed some of these over here. Obviously, if there's standing water, sometimes you don't see standing water, but you might see cracks in the soil. Sometimes your water looks very murky with these iron deposits. It can be extremely smelly. Often you walk into a wetland and it smells of rotten eggs. And then if you go into your car and sit there, your car permanently smells of rotten eggs, like mine does. But that's the hydrogen sulfide odor. Then there are algal mats that could form a film in a wetland. Sometimes you see crayfish burrows like the one up here on the right, and these can be really large. You can trip and fall over these if you don't really see them. Watermarks on trees, all these are indicators of wetland hydrology, and you need at least 2 secondary indicators and 1 primary indicator to fulfill that criterion of wetland hydrology. And finally, the most important thing is the vegetation. Vegetation needs to be hydrophytic. Now, based on what region you are in the United States, plants have an indicator status associated with them. So here in Illinois, we are primarily in the Midwest region. Ohio actually has 3 different regions to it. It's got the Midwest, the North Central, and the Piedmont region. And all you do is there's a list available online. You look at your species and you determine what indicator status it has. The indicator statuses range from obligate, which means that most of the time, something like 99% of the time, a plant occurs in a wetland. An example of that is this Lysimachia terrestris, that swamp candle in northern Illinois, a picture that I took a few weeks ago. This occurs mostly only in wetlands. You will rarely see it outside a wetland. And on the other end of the spectrum, a plant might be an upland plant, which means 99% of the times it occurs in an upland area. You will not see it in a wetland. And there's the in-between indicator status. So for a wetland vegetation to be considered for any vegetation to be considered hydrophytic, more than half of the vegetation in terms of percent cover must be obligate or facultative wet. So the plants should have the designation of obligate or facultative wet. So for a wetland, all these 3 criteria that I mentioned have to be fulfilled. It must have hydric soils, it must fulfill the criteria for hydrology, and it should have hydrophytic vegetation. Only then can we call this a jurisdictional wetland. So if any 2 of these criteria are fulfilled, well, too bad, it's not a wetland. It might be a high quality site, but it's still not a wetland, unfortunately. So everyone's heard about wetlands, hopefully, if they haven't, they have now. They are important, and I just listed a few reasons why wetlands are considered important. They improve water quality, they prevent soil erosion, they provide recreational opportunities. People go duck hunting in wetlands. They control floods, they control and maintain stream flow. And they provide a unique habitat for wildlife, whether it be plants or animals. And there are uniquely adapted plants and animals, sometimes even rare and endangered species that are found in wetlands. So because wetlands are so important from an ecological standpoint, there is this push in the United States to conserve wetlands and to monitor and assess wetlands. So the EPA has what is called the National Aquatic Resource Survey. And as a part of that, they conduct the National Wetland Condition Assessment, also known as NWCA by most people. This is a nationwide push where several teams, actually 2 teams of people are sent for every state within the United States. They go out there and they examine the integrity of wetlands using a set of commonly used indicators. Now, these indicators could be physical, they could be chemical or biological. So they look at plants, they look at soil, hydrology, different kinds of environmental stressors, and chemical indicators as well, such as pH, bulk density, things like that. maybe not bulk density, but pH and other things. So this first started in 2011 and it's conducted every 5 years. So in 2016, I was fortunate enough to be living in Oklahoma, which does not have too many botanists. It certainly does not have too many people who want to go out in wetlands and get muddy and dirty. So I was able to be a part of this National Wetland Condition Assessment for 2016 in Oklahoma, and I headed the vegetation team. So currently, this is 2021, and there is this nationwide effort going on where there are teams of people in every state, and they're surveying wetlands. So they might survey anything between 30 to about 100 wetlands for every state within the US. So the goal of this is ultimately to provide government agencies, scientists, and the public with information about the quantity or the area, the acreage of wetlands in the US, and the quality or the health of wetlands in the United States. So in addition to this national level huge effort, several states have their own wetland program as well. So Ohio has the Ohio EPA. They have a blurb on their website about wetlands. Kentucky, and I lived in Kentucky and I'm working on some data from there, and that's why I have that in here. They have their wetland program plan, so does Arkansas, and several states have their own wetland program plan in addition to the NWCA, because there is such a nationwide and statewide push to protect and conserve wetlands. Similarly, Oklahoma has what is called the Oklahoma Wetlands Program Plan. And this is a multi-agency effort. It's the Oklahoma Conservation Commission, a couple of universities and tribal agencies in Oklahoma that have gotten together and come up with a program plan for protection of wetlands and conservation of wetlands in Oklahoma. And the core elements are listed here on the left. But most importantly, monitoring and assessment is what I'm going to be talking about, is within these core elements of the Oklahoma Wetland Program Plan. So monitoring is the systematic observation of current and changing conditions of a wetland. And then when there's analysis done on the data that is collected and using these data to make any kind of management decisions, that's called assessment. And that's a picture of me on the right with a former student surveying a wetland in Oklahoma. So the Environmental Protection Agency has this framework for wetland assessment, and you can think of it almost as an inverted triangle. And you can imagine your wetland right at the bottom over here. There are 3 levels. There's level 1, which is a landscape level assessment. So it's not really in the wetland, it's actually outside of the wetland. Level 2 is a rapid field assessment method, which is sort of near adjacent to a wetland, sometimes within a wetland, but not quite. And then there's level 3, which includes functional and biological assessments, which are conducted right within the wetland. So the question a lot of people try to ask and answer is, can these levels 1 and 2 serve as proxies for level 3, intensive assessments? So level 1 assessments are indirect methods. These are more shortcut methods. They are cost effective, and they use data from geographic information systems and remote sensing, land use, land cover data. It's more of a geospatial analysis. So if here's your wetland, there's all this land use, land cover around it, data from here are used to assess the health of a wetland. There are many people out there who are really good at this. They know how to use these GIS tools. About 20 years ago, I remember GIS was kind of a new thing. and students were trying to take classes in GIS, and I never really bothered. Maybe I should have. But nowadays, every other person knows how to use these GIS tools. So it's relatively simple to do. You can just sit in your nice air-conditioned office. You don't have to be out there with ticks and chiggers and get hot and dirty. And you can conduct these assessments right from the comfort of your office. So people have looked at level 1 studies. There's this paper on the left from 2007 looking at levels 1, 2, and 3 in Florida. And we looked at something along those lines with our Oklahoma data. We wanted to see if land use can indicate wetland floristic quality, which is level 3. And we didn't get very good results. So we're not big fans of that level 1 methodology. Level 2 assessments are also indirect. This uses simple field indicators that are in and around the wetland. So you can use things such as percent invasive species, buffer width, bare ground, presence of litter and duff, things like that. Whether there's any sign of human activity such as fences or roads, any proxies of wetland stress. It's a rapid assessment method. It's a combination of biotic and abiotic factors, and it uses a series of these stressors. So you don't have to actually go into the wetland. Now you're getting out of your office in your air conditioner, but you're still going to drive to the wetland. You might go to the fringe of the wetland and look at it. You might have to go inside, but you're not spending a whole lot of time. The idea is this is a rapid method. You can actually do this in about 20 minutes to half an hour. And these methods are well established. The United States has what is called the USA RAM. Ohio has its ORAM. Rhode Island has its RIRAM, and so on. And somebody's developing that for Oklahoma as well. And once again, people have looked at this in various contexts. We looked at it in Oklahoma as well, and what we found was that rapid assessment did not predict and classify wetland floristic quality. So when we're looking at proxies, we were saying that people are looking to see if level 1 and level 2 can actually replace level 3 assessments. We didn't think so. So what are these level 3 assessments? These are intensive surveys that are conducted for the entire assemblage, whether it be the flora or the fauna, within that assessment area of the wetland. And there are multimetric indices such as the Vegetation Multimetric Index, or IBI, specifically the Vegetative Index of Biotic Integrity for Ohio that John Mack and others have come up with that are used. And then there's Floristic Quality Assessment Index, which can also be a part of these VMMIs and IBIs and so on. So the Floristic Quality Assessment Index, or FQI, is a part of these multimetric indices. And here's a paper that shows you this Vegetation Multimetric Index. And I pulled this out of that paper just to show you that it relies on floristic quality. There are all these metrics that are used that all pertain to floristic quality. And truly, as the word said, the VMMI suggests, it is a multimetric index. There are lots of metrics that are used in this. Now, the Floristic Quality Index was first proposed by Floyd Swink and Jerry Wilhelm in the 1970s, in the late 1970s, to describe natural areas of the Chicago region, specifically prairies of the Chicago region. It has since then been used to identify natural areas, to evaluate the worth of natural areas, for prioritization purposes, for restoration monitoring, for compensatory mitigation. And although we love to write and say this whenever we talk about FQI, that it is used in other countries in the world because it was used once in Italy and maybe once in India and once in China, it is primarily something that is used in the United States and a little bit in Canada. Here's a map on the right that depicts coverage of floristic quality, or FQ. And about 2/3 of the eastern United States has coverage, and you see it in Alberta and Vancouver as well. Now, floristic quality index is a combination of three things: of species richness, ecological conservatism, and native status. And this index has been used for many years. It has been described in many different ways, but the simplest form of this index is simply mean C, and mean C times the square root of species. These can be native species or all species. And again, there isn't consensus about which formula to use. One of the papers that we're working on currently, we've suggested a slight variation to this formula. So floristic quality assessment index is based on coefficients of conservatism. These are values that are assigned by expert botanists, highly experienced botanists. Sometimes it's even a whole panel of botanists. They're assigned to every state or every region, and they vary from 0 to 10. All non-native species are automatically assigned a value of 0 for the most part. There are some states that are adopting negative values to non-native species, but we won't delve into that right now. So lower values indicate species that are relatively tolerant, those that are weedy, opportunistic invaders. And then higher numbers are assigned to species that are generally intolerant of any kind of human disturbance. So these perish very quickly when there is human disturbance. And it's not a rarity index, though sometimes some people do think of it that way, because often rare species are assigned higher values, though that's not always the case. So the Floristic Quality Assessment Index was first described in this book by Swink and Wilhelm, but at least for the Chicago region, we now have updated C values. Wilhelm and Rarica recently published The Flora of the Chicago Region, which is this amazing, some 20-pound book that has C values listed for every species, along with a wealth of ecological information, taxonomic information, and morphological information for all species. Ohio has its own technical report on FQI that came out in 2004. Andreas, Mack, and McCormick wrote that. So most states have their own FQI reports. So remember, these C values differ from region to region or state to state. Although FQI has been used for a few decades now, there are still some challenges with FQI. Ultimately, you do require taxonomic expertise because you're going to go out there and you need to sample an entire assemblage of plants. And to do that, not everybody is able to do that unless you have some level of training, botanical training. And it's also very time consuming going out there and sampling an entire assemblage like that. Then we have the issue of background noise. Not all plants flower at the same time. So there's the phenology problem. You go out there, you try to capture the most you can. Suppose you're going out in June or July, you're inevitably missing plants that flower early on. And you're also going to miss plants that flower later on, such as members of the Asteraceae or the smartweeds, Persicarias. You can't really identify them without their fruits. If you miss sedges, for example, look at this meadow. It's dominated by a sedge. Now, if this is a sedge that happens to have a high C value, you're going out to sample in June or July, it's already done flowering. There's no way that you're going to know what it is, and thereby you're missing a huge component. Now, there are people out there that I have gone with in the field that are experienced and can identify a lot of things vegetatively, but ultimately not everything can be identified vegetatively. There's also the problem of species area relationships. The larger the area, the more species you're going to encounter. So if you're looking at a wetland that's very tiny, as opposed to a wetland that's very large. Inevitably, the one that's smaller is going to have a lower FQI, and the one that's bigger might end up having a high FQI score. So that can be problematic. There can also be environmental heterogeneity within a given wetland. And these C scores, there can be regional variability. So think of the state of Oklahoma, for example. It has only one set of C scores assigned to the entire state. But if you think of the panhandle in the northwestern corner, the plants over there, the surroundings are going to be very different from those in the southeastern corner that's heavily forested. So that regional variability can be problematic with FQI. In the past, FQI was criticized because it is based on expert opinion. A bunch of botanists get together and they determine what those C values are going to be. So it is a little subjective. However, there are studies that have been conducted that have disproven that myth. It's actually just a myth. Those coefficients of conservatism are valid, they are robust, and here are two papers if anyone's interested in looking at them. My colleagues at the Illinois Natural History Survey authored these papers where they found that experts and models can agree on these coefficients of conservatism and that they are robust. If anyone's interested in looking more into what floristic quality assessment is, here is a good review paper. It's an easy read. It's a little long, but it is interesting. Written again by one of my colleagues at the Illinois Natural History Survey. And it talks about, it's a critique, it talks about the criticisms, and it also defends FQI. So ultimately, with FQI, it requires a lot of taxonomic expertise and time. And there are fewer and fewer people out there who have that botanical knowledge and who want to spend that kind of time doing these complete, comprehensive lists for any wetland. Those other methods, such as level 1 and level 2, might work for some people, but ultimately they are not biological. So that makes a good case to look for approaches that are biological yet rapid, because we don't have necessarily, the people who go out there don't necessarily have the time and the expertise. So they need something rapid, but it has to be biological. So to get around that, people have been looking at FQI considering only dominant species. So one approach is to go into the wetland and only look for dominant species alone. That is gaining a little bit of traction. Some people are looking at a list and completely ignoring graminoids, rushes, grasses, and sedges, and they claim that it does work for that as well. And of course, I could not believe that. I was skeptical. So I'm working on a paper currently looking to see what happens when we ignore non-natives and non-dominant species and how problematic it can be with FQI. But that's something for another time. Which brings us to the crux of the talk for today. Making a case for indicator species. Now, indicator species, just as the name suggests, are species that will indicate a particular group of wetlands. We did some original study with a small set of wetlands, some 55 wetlands or so in Oklahoma, and we found some indicator species. I then found a graduate student who came along and decided she wanted to take it further and look into indicator species. So these were our preliminary indicators from Oklahoma. And let me just give you one example very quickly. This is our scenario. So if you are in a wetland of high quality, so reference quality refers to high quality wetlands. If you're in that wetland in a prairie ecoregion in Oklahoma and you encounter this species, Corpus cyperinus, which is bulrush, it means that you are automatically within a reference quality wetland. So what this does, it circumvents the problem of knowing the entire flora. All you have to do is know a handful of species, just learn those and try to look for those. And if you encounter those, you can stop your search and right away you know that you've reached a high quality habitat. So it's rapid, it's biological, and it saves a lot of cost and time. So for our study, we looked at 120 non-forested wetlands scattered across 9 different ecoregions in Oklahoma. These were mostly emergent scrub shrub type of wetlands, mostly depressional wetlands, while some were seeps and fringes. And they varied from highly degraded wetlands like you see over here. This was right next to a Walmart, to nice protected wetlands. This was within a national wetland, an NWR, a national wildlife reserve. Oops. So for our sampling, we did one-time surveys and we used the EPA methodology as well as meander searches. And we identified all vascular plant species. We tried to identify most of these in the field, but we had to bring some back, those that are difficult to identify in the field. We spent many hours at the end of difficult field days in really crappy motel rooms that were infested with bed bugs and roaches and crickets. And we keyed these species out. Some of them we ultimately took back to the lab, and under the microscope, we used a variety of regional, state, and national level keys to correctly identify these plants. We then assigned C values obtained from Ewing and Hoagland. And this was the EPA protocol where we had at least 5 plots that were in the center of the wetland. Each plot was a 10 square meter area. We found 432 distinct species represented by 86 families, and the genus Carex, which is the genus of sedges, was the most species rich with 17 species. So for our objective, we had a 2-prong objective. Our first objective was, do we find better indicators with greater spatial environmental context? And for that, this was the student whose picture I showed earlier, Tommy Fouts. She kind of led this effort, and we published our results in this paper in Conservation Science and Practice. So to answer that question, we stratified our wetlands into different levels. We had 3 levels of stratification. We looked at non-forested wetlands in prairie ecoregions. So it was all non-forested wetlands, but specifically within this ecoregion. We then stratified them based on the hydrogeomorphic class. So we just looked at depressional wetlands within prairie ecoregions. That was our second level of stratification. And for the finest level of stratification, we looked at depressional wetlands specifically in the northern central Great Plains ecoregion of the prairie ecoregion, which is this gray area over here. So these black dots are our depressional wetlands, and the gray area is the CGP ecoregion. For our analysis, we used the indicator value analysis for species combinations, and we used combinations, meaning pairs, triplets, and quadruplets, in addition to singletons, because in our input matrix, because under the assumption that multi-species indicators cover more niche space and environmental heterogeneity than any single species would, and thus they would offer stronger indicator values. And we found a whole bunch of potential indicators at 3 different levels. This indicator value is based on fidelity and ubiquity. It is the product of the 2, where the maximum value would be 1. Fidelity refers to how exclusive a species is to the target group, and ubiquity refers to how frequent a species is within that group. And if you don't understand any of this, that's fine. It's not that easy. The whole point is that the maximum value you get is 1. The higher the value, the stronger the indicator. So when we look at our results, this is our coarsest level of stratification with all sites, and this is our finest level of stratification with the CGP depressions. And we see a huge jump going from all sites to CGP depressions. So we do get stronger indicators with increased stratification, not much going on at this level. So our next objective was, are there indicator species for high floristic quality? Do they actually exist? And if they do, can we extract these indicator species for depressional wetlands in the US Southern Plains? And not just Oklahoma, because these ecoregions extend into other states as well. So we just got a review back for this manuscript, and it's under revision. Hopefully it will be published in the next few weeks once we're done. So in conclusion, yes, our indicator species performance does improve considerably with stratification. But is that going to be enough for practice? With these other methods, other shortcut methods, such as rapid assessment methods, they are currently widely accepted. When it comes to FQI using that dominant only approach, it is gaining traction. So indicator species have been considered passé, and they have been written off in the past. So for these to be used in practice, they have to perform better than these other well-established methods. So our next project is to compare indicator species to other shortcut methods, which is rapid assessment method and an FQI using dominance only for this large data set that we have from Kentucky. And that's a potential student project because we have lots of projects going on and not enough time and not enough people. So that was just a little bit of the work that I've been involved in. But the main thing that I've been interested in is trying to incorporate species relatedness in bioassessments. So when we talk of bioassessments, pretty much everything that I talked about today involved floristic quality assessment, and that's an ecological index. And then there's this whole dimension of phylogenetic relatedness that has been ignored when it comes to bioassessments. So I've been looking at the intersection of floristic quality and taxonomic distinctness, which is perhaps the simplest way to incorporate phylogenetic relatedness of species. I'm also working on this endeavor which is a collaborative effort where you want to see if C-scores can be assigned to species that currently lack C-scores in other states based on functional traits. And then we recently got a grant from the Illinois Native Plant Society to come up with a prioritization scheme for sand area wetlands in Illinois. So we're looking at 14 different sand area wetlands this summer, and then we're going to come up with a prioritization scheme with floristic quality, taxonomic distinctness, and local contributions to beta diversity. And we hope to expand that to all sand area wetlands in Illinois and apply for bigger grants. Finally, I would like to thank the people who have been responsible for some of this research. My colleague, Jason Breed, who is the design and analysis guru, and my student, Tommy Fouts, who took the lead on some of the work that I presented today, the indicator species analysis. Dr. Bruce Hoagland, who is perhaps the best botanist in Oklahoma, and he assigned C values to all of our plants. The student workers who have assisted in some of the field work, and of course, all the funding agencies. And this book, The Flora of the Chicago Region, is actually around 20 pounds heavy, and he makes it look like it's not heavy at all, but it is. Pictures can be deceiving. Finally, I will take any questions, and feel free to email me at this email address on the right. If you want any of my papers, I will be happy to share them with you. Thank you.
Thank you so much, Suneeti. That was wonderful. Let me check the chat. Abby C said she loved your description of where you were staying when you were doing some of your surveys. Very visual, she said. So there's no questions in the chat. So would anybody care to ask questions just on the fly? And you can stop sharing if you want, Suneeti.
All right.
I'd like to ask a question about whether a beaver pond or when a stream gets dammed up by a beaver, whether that qualifies as a wetland.
It does actually. That's a great question. We did have some beaver ponds as well, but most of our wetlands were depressional. So because we had a large sample size there, we decided to focus on that category. But yes, beaver ponds are wetlands. Yes, for sure.
They can't really be a problem. So in most suburban areas, like out in Menor, where I used to live and still oversee trees out there, there was an area that was the Kellogg Creek was dammed up. It ran parallel to Route 84 and went into the Grand River. But a street called Beaver Creek got dammed up. The Kellogg Creek right by the houses, and the beavers started chewing on all the trees in the backyard. So they can really be a problem. And speaking of problems, my siblings and I have an island up in northern Georgian Bay up in Ontario. And my sister woke up this morning and posted on Facebook her boat that was tied up at the dock. Can you see that?
No.
No.
Oh, I'm sorry.
It's a little hard to see and not everybody has their screen up, Fred.
I can see it.
Yeah, well, apparently the beavers had a house under the dock, which has from a cedar swamp timbers. And then they decided to build a second story up inside the front of the boat. So that's it's been a real problem up there. Everybody has had problem with beavers. But it's a situation where I've seen where beavers have actually gone up into a stand of big tooth aspen, and the stand was so thick that none of the trees actually hit the ground. They were all hung up, and it was probably 100 yards higher than the pond. So they really can get around and cause a lot of damage. But I suppose that it would take a long while for a beaver pond to become a really good wetland.
Well, in terms of land management, yes, it's a big problem and depends on whom you ask. So land managers don't like beavers, that's for sure. But in terms of plants, it really depends on the surroundings. And yeah, usually it's just kind of ponded water in the center and it can get really deep. And it's the fringe that seems to have the nicer vegetation around it.
Quite a few decades ago, I had to do a wetland inspection down in Solon, Ohio. Industrial area was going to be developed, and the engineer who did the initial study claimed that any place where there were ruts filled with water was a wetland, and yet there were hickories growing there, and it was just the ruts from the drill going in to take a soil sample. And there are several places like that, and I disqualified all of them. But in walking the site, there was the most perfect wetland. It was textbook. You could write a textbook on it. It was just maybe 100 feet or so in from the paved road. It would have been a great place for school groups to study.
Yeah, my whole perspective on wetlands has changed after coming here to Illinois. My job here, the first time we went out to look at a wetland, it looked nothing like the wetlands I was used to. It had not a drop of water. The vegetation was just terrible and exotic, and it was dry and about 100 degrees that day. But that's just how wetlands are. They're jurisdictionally, they are wetlands if all those three categories are fulfilled. They're not necessarily good quality habitats, but they can still be considered wetlands.
Thank you, Fred, for the question and comment. We're gonna turn it over to Mary Kay Evans in the chat. And she wants to know, will these assessment methods work to indicate changes due to climate changes?
Very good question. I'm certain they will. In fact, that's going to be a really long-term study. I don't know right now if anybody is doing that, but there must be people out there that are looking at that. So if you have data collected over long periods of time, actually, there are models, people who do theoretical modeling, and I don't really do any of that. But I'm more a field botanist who just goes out there and collects the data and then plays with it. But people who are able to do modeling, they can take snapshot data, level 1 or level 2, 3, any of these, and then predict what the health of the wetland might be due to climate change. But I don't know a whole lot about it.
Thanks, Mary Kay Evans. Does anybody else have any other questions for Suneeti this evening?
I have one. Suneeti, you were talking about indicator plants and trying to see if those indicator plants would be a quick way to assess if something was a wetland. And I'm just curious, did you say that there is a huge number of plants that can be indicator plants as opposed to being able to just come up with a list for, say, Northern Ohio, and citizen scientists could go out and look for those indicator plants to help out?
That's a good question. Actually, that tells me that I kind of flew over some of those things. I should have been a little bit slower. What this indicator species analysis does is it's going to narrow it down. And it's not just based on mathematical models in R that we're looking at. We're also botanists who are carefully studying these data. The point is to find just a handful of species that are indicative of a certain wetland type. So say for Ohio, if you're looking specifically at depressional wetlands that are high quality in Northern Ohio, if hypothetically, if we found these indicator species for those type of wetlands, if all we found was 3 or 4 species or 5 species, all somebody would have to do is learn how to identify those 3 or 4 species and go out there and look for those. And if they were able to find them, that means they are in those high quality wetlands in Northern Ohio specifically. Did that answer the question?
Are any of those lists ready for distribution to people that love to do citizen science?
I wish. Well, it's going to be ready pretty soon for Oklahoma at least, because that's what we're working on. But at some point, if we got our hands on data from Ohio, we could do a similar study in Ohio, or somebody else could do it. In fact, somebody just contacted me from South Dakota recently and said that they wanted to replicate that study for South Dakota. So in theory, it is a very nice tool and it's very practical, but there isn't one currently for Ohio, no.
Okay, we'll wait. Thank
Thanks,
you.
Kelly.
Thank you.
Roy has a question. Does your assessment work in the Midwest ever encounter evidence for the legacy sediment hypothesis of Walter and Merritt's 2008?
Oops, I don't know what that is. I don't know what
Roy,
the
can you hop on and explain a little further, please?
Can you hear me? Not very well, I suppose.
No, we can hear you just fine, Roy.
All right, the legacy sediment hypothesis of Walter and Merritt's is that in the East, anyway, that the operation of mills, especially sawmills, in areas. So you have the sawmills operating, you're taking down the forest, the fine sediments quickly get washed into the mill ponds behind the dams, rest there, and then ultimately those dams are breached and the sediment gets redistributed quickly downstream, and you get the entrenched stream channels that most of us are familiar with. In any event, the legacy sediment hypothesis says that there are many areas that have recent sediment accumulation, fine sediment accumulation that is anthropogenic. It's not naturally caused. And there's a debate about this. And I just wonder if in your assessments, especially of depressional wetlands, you ever run into this. But, you know, if you don't, you don't.
No, it's not something we've even considered because
Sure.
like my talk, we've only looked at plants and pretty much plant data alone to assess. And there are different ways, and soil being one of them, of course, to assess. So there are biotic, antibiotic factors people look at, and there's so much out there, can't do it all. So no, I'm just a botanist.
I just thought I'd ask.
All right, we have another question in the chat. How did you account for whether or not those indicator species may have been introduced to the site? Sometimes site history gets murky. I don't know if that's a wetland pun or not, but it's a good question.
Well, our wetlands range from being highly degraded, so probably everything was introduced in there, to being nearly pristine. So no, we cannot really account for whether it has been introduced or it's not been introduced. What we can account for is whether the species is non-native or not, whether it doesn't even have a wetland indicator status to it, not to be confused with our indicator species. But remember I said obligate, facultative, wetland, facultative, and so on. So yeah, the indicator species analysis is merely mathematical, and it's going to just spit out a whole bunch of species. But we didn't just blindly accept what it spit out. We went through each one of them, and there were some that were obviously not even wetland species, because sometimes you see these non-wetland species on the fringes of wetlands, and if they came up as anything, I as the botanist overruled that, because the non-botanists are going to say, oh well, this is the mathematical data and this is what the program's telling us to do. But no, we got to use our brains. We're not going to use non-wetland plants as indicator species for a wetland. So we did account for some of those things. We made sure that these species occurred in at least 10% of our wetlands. So we had this pruning tool that we used for that. By pruning tool, I mean something in a computer program, not an actual, not pruning shears or anything like that. So we did have some aspect of just our individual thought that went into all of this, but no, we couldn't account for whether they were introduced in terms of humans introducing certain plants or not, even though they're native. Well, in that case, that's very debatable. Everything's introduced. When dating back to how many hundreds or thousands of years ago, we don't know. So I don't really have an answer to that. We didn't account for that per se.
I have a question. You alluded to the need for more people to be in your field. What do you think can be done to increase the number of young people wanting to get into the field of botany and related fields?
Well, reduce screen time, first of all. I think there are too many people that I see, younger students who are just stuck to their phones and their screens, and they don't want to get out there. Get them to like nature, from a young age. And most importantly, in my opinion, teach botany in schools. It's something that is never taught until students reach college, unfortunately. And I've been in higher education here for many years. I've taught botany courses at several universities, and I was shocked to see that they have never had any kind of botany in high school, which was different from the kind of education I had. I came from India, and we were taught higher level plant morphology, for example, and taxonomy and all that starting in high school. So we had that nice basis from the beginning. But it's unfortunately very neglected here in schools and even in colleges. I see that push where it's neglected. Botany courses are becoming more and more optional, and students go to great lengths to avoid taking botany. I've had students driving about an hour away to another campus just to avoid taking a class with me, because they knew it was a hard class and they had to get outdoors and become uncomfortable in the process. So start early on and take them outdoors as much as possible.
We have
Thank
in
you.
Russia botany starting 5th grade. 5th and 6th grade, we have a botany, and 7th grade, we had zoology. So we didn't have science, like science, everything, little bit of everything. We had special courses of different sciences, like botany, zoology, anatomy, and like evolution, stuff like that. And chemistry was separate and physics was separate. And it starts from like 5th grade, actually. Like, well, physics was introduced in 7th grade, I think, and chemistry also in 7th grade. So it was like, and we had 10 years education, not 12. But we managed to get all this stuff.
That's
So-
great. What country was this?
What?
Where did you get your education?
In Russia.
Russia. That's great.
Yeah.
Wow. That's why some of the best botanists are from Russia.
Oh, really?
Armin Takhtajan is from Russia, a leading plant taxonomist of the past.
Great. I
Thank you,
have
Anna.
zoology, but I love botany too, and I'm trying to learn more.
It's wonderful.
Jennifer kind of wants to tack on to your response, Suneeti. A big problem is that our local and regional universities aren't even offering botany anymore. They're mostly focused on medical coursework. So
Right.
that may be also something. Brian also has a question. Do you have any tools to help citizen scientist organizations evaluate the health of the wetlands they assume some stewardship responsibilities?
Like I said, I cannot
Yeah,
do
it's
it.
kind of
alone,
like Kelly's
Brian.
question.
Maybe you need to do that. Is that Brian Gilbert?
It just says Brian, but I'm assuming it's Brian Gilbert out there.
No, I don't have any citizen science tools right now, but my colleague Jason, who is working on dragonflies and looking at wetlands and dragonflies, did have some citizen science paper that has come out for that kind of work. It's some huge endeavor with some 30 different people that he's recently published. So if you want, I can send you that. Maybe you can adopt some of those tools. I'm not sure.
Wonderful. Well, Connie says you rock. Keep up the great work. And Alex says the book Plant Identification Terminology and Illustrated Glossary is quite helpful, as botany has an endless list of vocab and technical terms.
Yes, I was just looking for that book right now. I have it somewhere here in my office. I love that book too.
Awesome. Well, does anybody else have any other questions before we wrap up this presentation? All right, no, just getting a bunch of love in the chat. So Suneeti, Friends of Euclid Creek would like to extend our most sincere thanks for you taking your time to share your wealth of knowledge with all of us. And hopefully you had a good time. And I want to encourage everyone to check out friendsofeuclidcreek.com, go to our events page. Our next presentation will be hopefully in person. We'll know that closer to the date, but the title of our next presentation will be Healthy Watersheds, Healthy People, an Epidemiologist Perspective by Layla Jackson from Northeast Ohio Regional Sewer District. And that will be on Tuesday, September 8th at 7 p.m. And check our website and all of our social media and all that good stuff a little bit closer to that date for the location. So again, thank you, Suneeti. That was absolutely wonderful. And we'll be posting this online soon.
Thank you so much for having me. I really appreciate it.
Thank you.
Excellent.
Thank you.
Have a great
Thank
day.
you
so
And this
much.
was your first Zoom meeting. You did awesome.
Yeah.
That was a great job. Thank you.
Thank you.
You're a pro. All right.
Bye.
All right. We'll see you next time. Bye-bye, everybody. Thank you.
Bye. Thank you, Steve. Good
Oh, no
job,
problem. My pleasure.
as usual.
Yeah.
You're an expert. You're a genius.
All right. Well, I'll see everybody later. Take care.
All right.